Assalamu alaikum everyone. Welcome you all, and today I'm here again with a very recent paper, Mechanics Paper 4 for May-June 2025. So let's begin. Question number 1. Question number 1 says a crate is being pushed in a straight line along a horizontal surface by a force of magnitude 25 Newton. Okay, so this whole scenario is given to us. So let's side by side make a diagram for it to understand the whole situation in a more better way. So they say a crate is being pushed in a straight line along a horizontal surface by a force of magnitude 25 Newton inclined at 20 degree above the horizontal. So what kind of a surface do we have? We have a straight horizontal surface that is at a 20 degree angle. Okay, so along with that, let's also make the horizontal surface. Now a crate, so let's imagine a crate to be here, and now mention the force. Okay, so the crate is being pushed in a straight line. So pushed means it is pushed upwards. Okay, so if it would be pulled, then pull means it is pulled downwards, but it is pushed means it is dragged upwards. Okay, so a force of 25 Newton. So let's assume that the force is applied here. Okay, of 25 Newton. So 25 Newton is applied. Okay, then we have 20 degree above the horizontal. That means this is the angle. The crate moves a distance of 12 meter in 8 seconds. So let's assume 12 meter is covered in 8 seconds. So this is 12 meter. No, it's not making. Okay, fine, no problem. This is 12 meter in 8 seconds. So also underline this information with constant speed. So this is also an important thing that given to us, that at constant speed. Find the constant speed of the crate. So to find out the constant speed, we can simply use, for part A, we can simply be using S equals to V times T. Okay, because we have a constant speed, and we know that what do we need to find? We need to find the V. S is given to us to be 12 meter. That is covered in time 8 seconds. So we will be getting V to be equals to 12 over 8. That gives us to be 3 over 2 meter per second, or we call it to be 1.5 meter per second. Secondly, let's get to part B. Find the work done by the 25 Newton force. Okay, so let's talk about work done. We know what is work done. We have work done to be like force that is exerted in the direction of the distance covered. Okay, so if force is applied 25 Newton to drag this to 12 meters, okay, so what would be the work in dragging it to 12 meter? Force that is applied in the direction of the displacement and multiplied to the displacement. So normally we have F dot D, but as this is an inclined force, like the force is not acting in horizontally in the same direction of the displacement. So we will be finding the first the components. So for that reason, let's break this. it would be like this. Okay, and like this. So what is your angle? The angle would be the same 20 degree in between. And this will become 25 sine 20 opposite to the angle. And this will become 25 cos 20. Okay, so in this way, let's write this to be, it will become F cos 20, like force is 25 newtons, so 25 cos, or you can write first F, the force component along the direction of displacement to be F cos theta, and times D. So F we have to be 25 and cos of 20 degree times displacement is 12 meters. So when we multiply this all, we'll get it to be 281.9077. So here we are done with part B. Now let's get to part number C. And part C says the power at which, find the power at which 25 Newton force is working. So we know the formula for the power to be F dot V. And what is F in this? F must be that force that is making it move, that we call to be driving force. Okay, and now we will be, as we don't know about the velocity, velocity at which 25 Newton is working. So we'll find it to be, yes, we know the velocity, we just found it to be 1.5 meters per second. So let's substitute that. What is the driving force? Again, the same thing, the force that is making it move upwards along the displacement is 25 cos 20. So 25 cos 20 times velocity, and that is 1.5 or 3/2. So solving it will give you, that gives us 35 point 35.2384. So yeah, that's all about your question number 1.